Hello students and welcome to my channel Maths Hub. So today in this video I will trace a polar curve and show you what points do we need to take care while tracing a polar curve, right? So if you haven't watched my previous videos on symmetry and asymptotes on polar curves, do watch them. So let us try to trace the curve r square equal to a square cos 2 theta, right? Now firstly we will check the symmetry point, right? So all these points, they will help us to trace the curve in a simplified manner, right? So you can see first of all that r is carrying a square. So if you change r to minus r, there will be no change in the curve, right? That means the curve is symmetrical about the pole, right? The curve is symmetrical about pole. Okay. Now another thing that you can observe is there is cos. So if you replace theta with minus theta, then also the curve will remain unchanged, right? So the curve is also symmetrical about the initial line, right? So we get two lines of symmetry. One is pole and the second one is the initial line. That means theta equal to 0, right? So now let us check whether it passes through the pole or the origin. So let us put r equal to 0. So we will get a square. Cos 2 theta is equal to 0. So that implies cos 2 theta is 0. So when is cos of any angle equal to 0? Whenever 2 theta will become n pi. So we have to write a general value n pi plus pi by 2. Right? So from here we get theta is equal to n pi by 2 plus pi by 2. So what are the possible values of theta that we will get? We can put n equal to 1. So what do we get? Pi by 2 plus pi by 2 is theta equal to pi. Then you can put theta equal to 2. So you will get pi plus pi by 2. So that will be 3 pi by 2. Sorry. This is pi by 4. Sorry. So when I put n equal to 1, so I'll get pi by 2 plus pi by 4, right? So that will become 3 pi by 4, right? Similarly, when I put n is equal to 0, I can write the first value as pi by 4. Then I can write 3 pi by 4. When I put n equal to 2, I will get pi plus pi by 4. So that is 5 pi by 4 and then 7 pi by 4 and so on. So these are all the tangents to the curve at the origin, right? So all the real values of theta that we will get, they are the values of the tangents, right? Okay. So now after getting symmetry and pole, let us move on to the next, that is whether it has an asymptote. Now for asymptote, I told you that you have to calculate 1 by r first, right? So it's a square. So if I check r, it will become a under root cos 2 theta. So it will become complex. So there is no asymptote in this curve, right? And then let us try to check which regions do we get, right? So if I check the simple trigonometric relation, we know that all the sine trigonometric relations, they are positive in the first quadrant, right? Then only sine is positive in the first quadrant, tangent is positive in the third quadrant, and fourth quadrant cos is positive. That means cos will be negative in second and the third quadrant, right? So that means whenever we have 2 theta lying between, second quadrant is pi by 2, 2 pi, and the third quadrant is between pi and 3 pi by 2, right? So whenever theta lies between pi by 4 and pi by 2, and similarly whenever theta lies between pi by 2 and 3 pi by 4, then cos will be negative, right? And if cos is negative, r square will become negative. So r square cannot be negative. That means within these portions between pi by 4 and pi by 2 and between pi by 2 and 3 pi by 4, there will be no curve, right? So no curve, no part of the curve will lie in this region. So I hope this is clear, right? Okay. And what is the maximum radius that this curve can take? So you can take a mod. So mod of r square is equal to mod of a square mod of cos 2 theta. So we know that mod of cos theta is always 1. So we can say that mod r is equal to mod a. That means the maximum radius of this curve can be a. Right? Now with all this information, let us try to trace this curve. So let us first of all draw the axis. So it's a bit distorted line. So just pardon me because it is very difficult to draw it, right? So, okay, I'll try. And now let us first of all check what were the tangents. The tangents were theta equal to pi by 4. So I'm drawing with the help of a dotted line. Then we had theta equal to 5 pi by 4 was also the tangent, right? Then we also had theta equal to 3 pi by 4 and theta equal to 7 pi by 4, right? So theta is equal to 3 pi by 4 and theta equal to 7 pi by 4, right? And what did we check? That theta did not lie between pi by 4 and pi by 2, and also theta did not lie between pi by 2 and 3 pi by 4. These were the two regions where R do not have a, the curve do not have a region, right? So if the curve does not have anything between pi by 4 and pi by 2 and between pi by 2 and 3 pi by 4, that means no part of the curve can be in this region, right? So, and the maximum radius is A. So this is A comma 0. So how will the curve go? This is the tangent. So this is how the curve will look like, because the curve was also symmetrical about the initial line. So whatever curve is above this theta equal to 0 line, the same thing will be below it, right? And the same thing we will have here also, right? So there is no portion of the curve in these two portions. And this is minus a comma, right? So I hope you have understood how to trace this curve, right? So thank you so much, and believe in yourself. You will definitely do it. And do subscribe my channel to get the latest updated video. Have a nice day.